Okay, so guys and girls, let us start today's lesson, and the name of the chapter is ammonia. This is a new chapter, ammonia. This is a small chapter, and we'll try to finish this off in today's live stream. First, Haber process. Now, Haber process is basically the industrial manufacture of ammonia. Ammonia is NH3. I suppose you all already know that. So, but anyways, I'm going to write the formula of ammonia. If you do not know the formula of ammonia, it is NH3. Okay, now industrial manufacture of ammonia. See, first of all, we need some initial materials that we are going to use in this manufacture, and those materials which are used in any industrial process to begin, those materials are called raw materials. And the raw materials for this Haber process are nitrogen and hydrogen. There are two raw materials. One is nitrogen, its formula is N2. And how do we obtain that nitrogen? The source of that nitrogen, see, nitrogen is present very abundantly in air. Air is 78% nitrogen. So what we do, we capture some air, we liquefy that air, and then carry out fractional distillation to separate its components, and thus we obtained nitrogen. So its source is fractional distillation of liquid air. The next raw material that is needed for this process is hydrogen. The formula of hydrogen is H2, and the source of hydrogen is the cracking of hydrocarbons. See, if you have already studied organic chemistry, then you must be familiar with this term cracking. That cracking process also releases hydrogen gas, which is stored and then used in different various processes. One of them is Haber process. But if you have not studied organic chemistry yet, then you do not need to go into the details of this statement. You just need to remember this, that the source of hydrogen in Haber process is cracking of hydrocarbons. We obtain hydrogen from the cracking of hydrocarbons. You will get familiar with these terms, hydrocarbons and cracking, later on when you deal with organic chemistry. Okay, now the reaction. See, I will give you a moment to note this down. After that, I will write the reaction at the top, and because I will have to keep that for later explanation too. So the reaction which takes place during Haber process is very simple. Simply nitrogen reacts with hydrogen to form ammonia. Let us balance the equation. A 2 with ammonia and a 3 with hydrogen, we have a balanced equation. Let us put the state symbols. See, this is a gas, this is a gas, and ammonia is a gas too. These are all gases. And the enthalpy change of this reaction has a negative sign. It is negative. That means it is an exothermic reaction. You don't need to learn the value of the enthalpy change. Okay, so now this is an industrial process. We can simply form ammonia by reacting nitrogen with hydrogen. We already have obtained them as raw materials. But the problem is that naturally this reaction is a reversible reaction. This thing is linked to the segment reversible reactions and equilibrium which we studied in the previous class. So basically, in an industrial process, whenever there is a reversible reaction, there is always a low yield of products. And this is an industrial process. We want a high yield, otherwise the ammonia produced will be too expensive if the yield of the reaction is low. So by using our knowledge of equilibrium and the factors affecting equilibrium, we would introduce a few problems. See, the first condition, the temperature we use for this reaction industrially is 450 degrees C. The pressure that we use for this industrial process is 200 to 300 atm. Then we use a catalyst. The catalyst in this case we use iron granules as catalysts. Then there is another condition. We continuously keep up adding nitrogen and hydrogen to the reaction mixture in a 1:3. And there is another condition that the ammonia produced during the reaction is continuously being removed. We do not wait for all the ammonia to be formed and then to remove. No, we keep on removing ammonia continuously throughout the process, and we keep on adding nitrogen and hydrogen continuously throughout the process in 1:3. Okay, now without these 5 conditions, the yield of yield of ammonia in this process is close to 40%, in fact less than 40%. But when we use these right conditions, that yield increases to 95%. So after putting these 5 conditions, we obtain a 95% yield of ammonia. Okay, now let us try to understand why these conditions are helpful, how are these conditions necessary. I want you all to answer one by one. First, we are dealing with temperature. What I want you to do is that I don't want you to look at the conditions. I just want you to look at this part at the top where the reaction is given. Just look at this part and tell me, we want a high yield of ammonia. What should we do? Should we keep a high temperature or a low temperature? Use your previous knowledge. Use the previous knowledge from your previous class and answer me this. We want a high yield of ammonia. What should we do? Should we keep a high pressure or should we keep a low pressure? I'm waiting for your answers in the comment section. Do not look at the temperature. Just look at the reaction and tell me that whether we need a high temperature or a low temperature. Just keep yourself to the temperature and let the new students answer first. Those students who are studying this for the first time. Currently, I am asking you about the temperature, not the pressure. I said pressure once, that was by mistake. I am currently asking you about the temperature. What temperature should we use in order to increase the yield of ammonia? A high temperature or a low temperature? That is the question for now. Okay, most of the students have said that we should use a high temperature. Most of the students are saying that we have to increase the temperature. I've seen only two answers. One of them was from my older students and one of them was from new students. They said that a low temperature must be used. See, the answer is correct. Low temperature should be used to increase the yield. I told you not to look at the temperature. I told you to look at the reaction, and the reaction says the enthalpy change of the forward reaction is negative. That means the forward reaction is exothermic, and that from that we can assume that the reverse reaction is endothermic. And I told you in the previous class that high temperature favors the endothermic side and a low temperature favors the exothermic side. In this case, forward reaction is exothermic, reverse reaction is endothermic. So that means if we want to favor the forward reaction, we need to keep the temperature low. We do not need a high temperature for this reaction in order to increase the yield. So this means that we are using a low temperature. Now you all must be thinking that Sir Khurram has gone mad and he is saying 450 degrees C temperature, a low temperature. Actually no, I am still okay. See, 450 degrees C is not a low temperature for you and me at all. It is a very high temperature for us. But for this reaction, this is a low temperature. See, whenever we want to carry out a chemical reaction, we have an upper boundary of the temperature and a lower boundary of temperature, in which in that range that temperature can proceed at a significant rate. Below that temperature, the rate of reaction becomes too slow. That is useless. So we have to keep a temperature up to a level, we have to keep the temperature between a range, and in that range for this reaction, 450 degrees C is the minimum. So for this reaction, this temperature is a low temperature. For you and I, this is not a low temperature at all. We will not even survive in this type of temperature. But for this reaction, the range of temperatures at which this reaction proceeds at a significant rate, this temperature is to the lower side, to the lowest side between that range. So this is a low temperature. Okay. Now moving on to pressure. Again, I want you all to answer, and in fact, don't just answer the question, give a reason for your answer. And the students who have already studied this, don't answer first. Let the new students answer first. After that, you can comment too. So, new students, I am expecting the answers from you. We are using a pressure, forget the value of pressure. Just look at the reaction. Just look at the reaction and tell me, we want a high yield of ammonia. What should we do? Should we keep the pressure high or should we keep the pressure low? And why? Give a reason with your answer. I am waiting for your answers. Guys and girls, I am waiting for your answers. Only one of the students have replied yet. Okay, those of you who are giving me answers, can you write reason for your answer? Any other students, guys and girls, come on, improve your participation. It's okay to be wrong. It's okay if you give the wrong answer here. It is completely okay. It is not a test. I want you all to know this. This is not a test. This is learning. This is part of your learning. So I won't mind wrong answers. I want you all to participate. Please give your answers. Only 4 or 5 students are replying in the comments. Please, all of you, I want all of you to participate. Give the answers, whatever you think. It doesn't matter if it is right or wrong. I am there to explain that. I will explain you afterwards that what is the right answer. So please, other students, give your answers. Give me your answers with explanations, please. Only one student has given me explanation. Okay, yes. Those of you who have written the explanation, both of you were right. Uh, See, we need to have a high pressure in order to increase the yield. Don't just look at the pressure and assume this is high and low. Don't ever do that. That is why I explained you the factors affecting equilibrium position first. Then I brought you to this chapter because the explanations of this process are from the previous chapter, the reversible reaction and equilibrium segment. So yes, we need to have a high pressure because if you look at the reaction, there are two gaseous moles on the product side and there are four gaseous moles on the reactant side, and high pressure favors the side with less gaseous moles, and we want this to happen because the product side has less gaseous moles in it, so we want a high pressure, we want a high yield, it will favor that. So this pressure 200 to 300 atm is a high pressure for this reaction. Okay, now the next thing, the next factor we are introducing here is the catalyst, and we are using iron granules. I have two questions regarding this. First thing is the catalyst iron. Why are we using a catalyst? How is it going to affect the yield of ammonia? I want you to tell me the effect of using iron catalyst on the yield of ammonia. I'm waiting for your answers. Then I'll come to the second question about this. Guys and girls, I'm waiting for your answers. Yes, I can repeat the question. The question is that we are using iron catalyst. What effect will it have on the yield of ammonia? Okay, I'm getting some interesting answers from all of you. See, the first thing is that if you look at the previous notes, I told you that catalyst increases the rate of both forward and reverse reactions equally. So that will not affect equilibrium position and that will not affect the yield of ammonia. So yield of ammonia will remain unaffected by the use of any catalyst. So why are we using catalyst? It is being used just to speed up the chemical reaction. Catalyst is a chemical which speeds up chemical reaction and itself does not get chemically changed. So it will not increase the yield and it will only speed up the reaction. So the yield will remain what it already was, but it would obtain quicker. We will save time. We will not produce a more amount of ammonia. In fact, one student has stated that more ammonia and more speed. No, more ammonia will not be produced due to the use of a catalyst. More speed will be achieved because catalyst does not affect the yield. Okay, so now moving on to the Factor number 4, the condition number 4. Nitrogen and hydrogen are continuously added in one ratio. Okay, before that, I'm sorry, my apologies. I have to ask another question regarding point number 3, the condition number 3. We are using iron granules. Granules mean small pieces. So we are using small pieces of iron, not large lumps or not one large slab of iron. We are using small granules of iron. Can somebody explain what will be the effect of that? Why are we preferring small granules instead of large slabs? Okay, good. One student has answered it correctly, and the answer is that iron granules means that small pieces are being used, and small pieces means there is a larger surface area, and when the surface area is large, there is a higher speed of reaction. So catalyst already speeds up the reaction, and we are using granules of the catalyst. That is why it will speed up the reaction more effectively. Okay, now let us move on to point number 4. Nitrogen and hydrogen are continuously added in 1:3. See, this 1:3 is obviously coming from the ballast equation. Now I want all of you to answer that why are we adding nitrogen and hydrogen continuously? And please let the first timers speak first. Let the new students give their answers first. The old students can give their answers after that. So the question is, why are we continuously adding nitrogen and hydrogen? Why don't we add all of the nitrogen and hydrogen in the beginning and collect all the product in the end? Why are we adding them continuously? Production will still keep going better if we add all the nitrogen and hydrogen simultaneously. But we are continuously adding them. We have a continuous supply of nitrogen and hydrogen. Why is that? Even an old student is answering wrong. Come on, guys and girls, I'm waiting for your answers. Why are we continuously adding nitrogen and hydrogen? Okay, anybody from old students? Come on, guys and girls, participate more. See, I am going to tell the answer. See, the continuous addition of the reactants means that we are continuously increasing the concentrations of reactants. And increasing the concentration of reactants shifts the equilibrium position to the forward side and the yield of products increases. This is why we are continuously adding nitrogen and hydrogen. If we add up all the nitrogen and hydrogen in the beginning, the reaction will keep on going, but the yield will not be as high as in this case. Similarly, moving on to point number 5, the condition number 5, ammonia is continuously collected. Now in this reaction, ammonia is the product, and continuously collecting ammonia means continuously removing ammonia from the reaction mixture, and that means we are continuously decreasing the concentration of the product, and decrease in concentration of products again shifts the equilibrium position to the forward side and the yield of product increases. This is why these two conditions also help us to increase the yield of ammonia. So this is how we increase the yield of ammonia from 40% to 95%, and we have the best possible rate of ammonia. Now there are sometimes there are two relevant questions which are often asked in the examination. One question is about the temperature, another question is about the pressure. See, about temperature, in fact there are two questions. One question is that why don't we use a temperature higher than this, and the second question is why don't we use a temperature lower than this. I want you all to note down the answers. In fact, I will note that down for you. First, understand, we do not use a temperature higher than this because that will decrease the yield of ammonia. And we do not use a lower temperature than this, although it increases the yield of ammonia, but we cannot use a lower temperature than this because the rate of reaction will become too slow. Then the pressure. Again, they may ask you that why don't we use an even higher pressure than 300 atm. This is because the process will become too expensive. It will not affect that much on yield. Like if it is already 95%, it might increase the yield from 95 to 95.1% or even 96%. But still, the process will become too expensive. We will have to buy a huge compressor in order to exceed this pressure range. So this is not feasible. And why don't we use a pressure lower than this? Because that will reduce the yield of the product, and we want a high yield. So we do not use a pressure lower than 200 and we do not use a pressure higher than 300 because the process will become too expensive. Okay, so now I will note down these two relevant questions. Please note this down. These are some important questions. I've seen a question from a student that how will it reduce the yield of ammonia? Uh, what are you asking about, beta? Are you asking about the temperature or the pressure? Like you're talking about question 1 or question 4? I think you're asking about question 1. So, a higher temperature. See, I told you already that the forward reaction is exothermic, so a low temperature favors the forward reaction. If we increase the temperature, that means we are going to use a higher temperature. Higher temperature will shift the equilibrium position to the endothermic side, which is the reverse side. So, the yield of product will reduce. I've seen another question about the mole about 1:3. Yeah, but 1:3 we added 1 ratio nitrogen and hydrogen in 1:3 because these are the molar ratios of nitrogen and hydrogen from the balanced equation. Student has asked why did we use an even higher pressure? Here is the answer, beta. This will become too expensive. I have already explained it to you. Okay, guys and girls, let's move on to the uses of ammonia now. Ammonia is a chemical which is produced on a large scale, on a very large scale actually, and that is because of several reasons. One of the reasons is that it is used to make fertilizers. Can somebody tell me what is fertilizer? I'm waiting for your answers. Yes, guys and girls, what are fertilizers? Yes, very good. See, fertilizers are the chemicals that we add to the soil to increase the yield of crops, to increase or stimulate the growth of plants. They increase the rate of growth of plants. So, ammonia is used to make them. Now, fertilizers are the chemicals, as I told you earlier, that they increase the growth of plants. Now, which elements are responsible for that? Three elements are needed to make fertilizers. Any one of them present in a chemical can be used as a fertilizer. One of them is nitrogen, then phosphorus, and then potassium. These are the three elements which are main constituents of fertilizers. So basically, plants need these three elements in order to build up their proteins and other structures. So if we provide a higher concentration of these elements in the soil, plants grow at a faster rate. And nitrogen is an essential part of proteins. Ammonia is used to make those fertilizers which contain nitrogen. Okay, another large scale use of ammonia is in the industrial manufacture of nitric acid. Nitric acid is another important chemical. It has many different uses. The large scale use of nitric acid is in the manufacture of explosives. So nitric acid is used in the manufacture of explosives, and ammonia is used in the industrial manufacture of nitric acid. And ammonia is also used as a solvent. It is used as a solvent for many different chemical reactions which have different applications. You do not need to go into the detail of it for now. Just need to remember that ammonia is also used as a solvent. I will give you a couple of minutes to note this down. Then I have to give you an assignment for today, a homework, a little homework for today. Okay, you have homework for today, and for The old students, it is optional. If you have already done this, you don't need to do that again, you just have to revise it. But for new students, it is something compulsory. I will check your homework uh, tomorrow. So you have the homework that you have to write the explanations for all the conditions, the 5 conditions that we used in the reaction of Haber process. Those explanations I have already discussed with you in today's class. So that is not a difficult task at all. You just have to note down, you have to give a heading for the explanation of conditions of Haber process. That will be your heading. And then for condition number 1, write your explanation. Why is that condition being used? Then the point number 2, why is that condition being used? Your explanation in your own words. You can rewatch the video to get to revise how I explained those conditions. But I want you all to complete that, complete those explanations in a written form, and I want you all to take pictures of your work, those explanations, and send me through WhatsApp. I will be waiting for that. See, this is your today's homework, and if you still have confusion in how about how to explain the conditions, you can rewatch that segment of today's live stream later on again. And if and another thing, if you still have confusion, you in fact should watch the previous stream. The video of the previous stream has been saved right here to this channel. The factors affecting equilibrium position part. If you have confusion in that how these conditions work in Haber process, you must watch that stream first and then this stream again. You will understand this. I promise you that. If you still have any questions, let me know. Yes, but we will have more classes. In fact, I will not give you that long of a gap as the school has told you according to your schedule. I will keep on taking your classes on and off. I will keep you engaged with chemistry. Be prepared for that. But for now, you send me the homework by tonight or in the tomorrow morning, and we will have another class tomorrow on Saturday. Yes, we will have another class tomorrow. In that, I will explain the details of contact process. I don't want to delay that topic because it is related to this one. It is very similar to this one. It is related to the factors affecting equilibrium position. So we need to cover that up as soon as possible. I am planning to do it tomorrow, maybe the day after tomorrow, but my preference would be tomorrow. I will let you know in your WhatsApp groups. So even after that, after the end of this week's sessions, I will not just stop taking classes. I will keep on I will keep on taking classes on and off. Those would not be as regular as this week, but I will still keep on taking classes. So be ready for that. If you have any more questions, you can ask me now. Guys and girls, if you have any questions, you can ask me now. I'm waiting for your questions. Must complete your homework by tonight or by tomorrow morning and send pictures of your homework to me on WhatsApp. Alright, so I'm not seeing any more questions. So I will call this a day. I will end the stream now.